Today's daily dose of math is about tree diagrams. A tree diagram is a diagram that allows us to visually represent a probability situation and makes it a lot easier to see what we're doing when we're answering questions. Today's example is about buying a new shirt. There are 3 possible colors, red, blue, and green, that are shown here. 4 possible sizes, small, medium, large, extra large, and 2 possible types of neck, the V-neck and the crew neck. Now, this information doesn't have to be given in this form, and I could have used a circle to show the sizes if I wanted to. The student has to be able to take a look at the information that they're given and figure out what fraction goes with each of the choices. So we have 3 equal portions of this circle that are devoted to red, blue, and green, and that is the student's hint that there is a 1/3 chance of each happening if they're chosen randomly. So I write red, blue, and green at the end of the first set of branches of my tree diagram. And I want to put those fractions in place, a 1/3 chance of each happening. Next, I have to put the sizes. And there are 4 sizes, and I have to show the 4 sizes for the red part of the tree, but also for the blue and for the green. So tree diagrams have a tendency to get crowded and get larger very quickly. You can see by my smudge marks that I've been struggling with this one already. But I'm going to write the 4 possible sizes at the end of these second sets of branches. And I want to give the fractions probability. There are 4 sizes, and this diagram shows me that there are equal chances of each. So that means I have 1/4 that I'm writing, and I have to do this 12 times. So it is a little bit repetitive, but it is necessary. Finally, I can put in my V-neck or crew neck. Well, fortunately, there are only 2 choices, so the amount of branches that I need are smaller. But from each of these branches of the tree, I have to branch again into 2 smaller branches. And you can see how difficult it is to fit everything. There's V-neck or crew, so I will label them with a V and a C, and again, very repetitive. Finally, that's done, and finally I have to put the fractions for this. This is going to be long. There's half V-neck, half crew, so I need the fraction 1/2. And I'm writing that on all of these branches. Well, thanks for staying with me through all of that. So it has gotten a little bit messy, but if there is a teacher who is correcting the work that you're doing, so long as the teacher can find all the information that is necessary in the diagram, you're doing okay. Now, finally, we can answer the questions. How many possibilities are there of combinations of color, size, and neck type in this situation? Well, all this work makes it very easy to answer that question because the number of possibilities is represented by the number of final branches that I have here. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. We have 24 possibilities. And now a more detailed question. What is the probability of getting a small red V-neck? Well, if we're choosing at random with these fractions applied, the way of getting that probability is, again, much easier to answer after doing all the work of making the tree diagram. What I'm going to do is show an ordered triple. which is, first I want the color. So even though it says small red, mentions the size first, I'm putting the R first because the color was first in my tree diagram. And then a comma, then I put the size, which is the small, I'm putting an S, and a V-neck, so I put a V. And that is called an ordered triple, and that tells me which fractions I have to use to make my calculation. I have the 1/3 that goes with the red, which is multiplied by the 1/4 that goes with the small, and multiplied by the 1/2 that goes with the V-neck. The numerators multiply to give 1, the denominators multiply to give 24, which I knew was going to happen because I knew there were 24 possibilities. And then I just have to answer my question. There is a 1 in 24 chance in fraction form, but I can give that in decimal form and percent form as well. 1 divided by 24 is 0.0416, and this 6 is repeating. But then even more useful, multiply by 100, and I get the percent, which is 4.16, and I'm rounding 4.167%. All three of these are the right answer, but the good habit to be in that I encourage in my students is to give all three, so that no matter what they wanted when they asked the question, you're providing the answer in a form that they like. This is how we use a tree diagram to answer questions about probability in today's Daily Dose of Math. I hope you liked this video. If so, remember to give it a thumbs up, and if you're not subscribed yet, click on the subscribe button.